Hi, this demo shows the integration between the Avi Networks load balancer and OCI, as well as some of the capabilities of the Avi Networks load balancing solution. What we did is create a VCN for the sake of this demo. And inside that VCN, we have a bunch of different hosts. So we have the Avi controller. Now, the Avi solution is a decoupled solution, separate control plane and data plane. So the controller is the central management of the solution. It provides the source of truth for anything that's configuration. It manages the life cycle of the actual load balancers that we deploy into OCI. And this is also where you go for troubleshooting, monitoring, looking at metrics, debug logs, client logs, automation using our SDK or Ansible, Terraform, and so on. This is all done using the centralized management, the Avi controller. In addition to the controller, we have a couple of load balancing entities, what we call service engines. What we did, we deployed them in a couple of different availability domains. So we have a service engine in AD2, and we have another service engine in AD3. In terms of other hosts we have a couple of application servers that we called WebTest1 and WebTest2. We're going to use those app servers for HTTP, as well as for a UDP use case that we're going to show. And then we have one additional virtual machine that we will be using as the client. So we talked about the two service engines that we deployed into OCI. These run on OCI Oracle Linux VMs. If I go back to my controller, I have a bunch of apps already provisioned here on those two service engines. If I go to my infrastructure page, I can see the two service engines here. I can see that they're healthy. And if I go back to my application page, I can see that all of my applications are placed on both service engines. One of them has the notion of, one of them is being the primary for the app and the other being the secondary. However, these guys are active, so they both get and serve traffic for each one of the applications. If I go back to this view, I can see that different service engines can be the primary for any of the applications. So for this specific application, .6 is primary. For the other three, .5 is actually the primary, but again, it's active, so they'll both serve traffic for the applications. So what does it look like from the OCI perspective? If I look at my service engine here, and I look at the IP addresses attached to it, so I have the primary IP of the service engine. This is the IP it will use to communicate with the controller on the management path. And then I have three additional IP addresses here, three secondary IP addresses. If I look at my other service engine, it will look pretty much the same, where I have my primary IP and then I have a secondary IP. Now, those secondary IPs that you see here, as well as here, those are actually the VIPs for my applications. So if I switch back to the Avi UI, I can see those IPs here. Now, when we set up the controller in OCI, we actually set up IPAM. So whenever an application gets created on Avi, we can go and automatically grab an IP address using DHCP or using the OCI IPAM. So an IP address does not need to be specified manually when an app gets created on Avi. And I'll show that in a moment when I create a couple of applications. So let's start by creating a pretty simple web type HTTP application. So I'll go here, I'll choose to create it in advanced mode so you can see some of the features. Let's call this OCI Demo HTTP. This is the IPAM integration that I mentioned. So once integrated with IPAM, we can see subnets within the VCN, and I can just choose the subnet here. I don't have to specify an IP address manually. I can actually disable this checkbox and specify it manually if I wanted to, but for the sake of this demo, we'll do it automatically using IPAM. So I chose the subnet to get an IP address from, and what I'll do here is I'll create a pool for my application. Let's set it to round robin, and then add a couple of servers. So I do have a couple of servers here that I created in OCI. So this guy is 10.0, 10.4, and the other server is 10.0, 10.8. So let's add those two servers to the pool. And then let's finish creating the application. I'm basically just clicking through. The only change I'm going to make here is to select the correct service engine group. Basically, those two service engines that I showed, a part of the OCI group. I'll click Save. My application is created. It's already up and running and healthy. If I hover over the name of the app here, I can see that an IP address was grabbed from IPAM as the VIP, and my app is listening on port 80, and it's placed on both service engines in active-active. So I'll copy this VIP and run a couple of GET requests to the app, and let's see what's going on with it. I'll use my test client here. I'll do a simple curl to the VIP, and I get a response from WebTest2. If you recall, we set the pool to round robin, so the next request will go to server number 1. Now let's take a look at this from the Avi log perspective. So if I go back to my app here and look at the client logs, I can see the two requests that I generated. And if I look at the request, I can see my client IP, I can see some information about my host, I can see some load balancing information that was done within Avi, and then some layer 7 information about the request. I can see the host header, I can see the request method, the URI that was requested, the content type, response, and so on. And I can see that the application responded to my request with a 200 OK. I can also see that my request landed on this server, 10.0.10.8. Now, if I look at the other request, and if you recall, we configured the pool with round robin, I can see that the second request landed on the second server in the pool on 10.0.10.4. Now let's do something similar, only this time let's do it with offloading SSL on Avi. So I'll create another VIP. Let's call it OCI Demo SSL. I'll grab an IP address from IPAM again for the VIP. What I'll do here is I'll change the application profile to System Secure HTTP, and I'll show that in a moment. I'll add a port. Let's make it 443 using SSL. One thing to note here, you do not have to create separate VIPs for port 80 and port 443. This one VIP will actually listen to both ports. Additionally, on Avi, when you have a VIP that offloads SSL, you can attach both RSA and EC certificates to the same VIP. And as part of our System Secure HTTP application profile, and by the way, all those profiles are reusable across multiple VIPs, so you don't have to recreate them for every application you deploy. But as part of this System Secure HTTP profile, we have this checkbox to redirect HTTP to HTTPS. So as opposed to other solutions like F5, for example, this would require the use of 2 VIPs and an I rule. In the Avi case, that one VIP listens to both ports 80 and 443, and this checkbox will enable redirect of HTTP to HTTPS. I'll attach the same pool that we created in the previous example, those two web servers that I showed before. And let's finish creating this application. So again, my application is already up and running. I have a VIP that was grabbed from IPAM. My service ports are both 80 and 443. And I also have a redirect enabled from 80 to 443. So let's take a look at that. I'll copy the VIP IP address. Let's go back to my client and I'll do a curl. I'll do it on HTTP, meaning port 80. But what I'll do, I'll add a dash capital L that tells curl to follow any redirects, and a dash K because my certificate is self-signed and I don't want curl to complain about it. So let's send this request and see what happens. So I landed on server web test number 1. If I go back to Avi to check my client logs, I see my first request that came in on port 80 and was answered by the load balancer by Avi with a 301 redirecting the client to port 443. If I open the second request, I can see the actual SSL encrypted request that came into Avi. What I can see here is the SSL version that was used by the client, and I can see that the client was using EC as a certificate with perfect forward secrecy turned on. And as before, I can see the load balancing information as well as the layer 7 information, which VIP was accessed, and then which server in the pool handled the actual request. One other use case that we were asked to show that can sometimes be challenging in the public clouds is a UDP use case. So for this use case, I chose to use NTP. I just installed the NTP daemon on both web servers, on both those application servers. So let's grab this VIP, and what I can do for my client is a simple NTP date command against my NTP UDP VIP. So I can see that my client here got a response from the NTP server. And once again, we can dive into the client logs and see the request. So here's the latest request. Here's my client reaching out to the VIP using port 123, load balancing information, and then the request went to 10.0.10.8 using port 123 UDP, which is the port for NTP. And additional use cases that we demoed was the use of policies for any layer 7 manipulation. So content switching, for example, based on URL, based on path, based on header, and so on. So what I created here is an application. So here's my VIP, my front end, and I have two pools behind this VIP. So I have content switch pool and content switch pool 2. And what I did here, as opposed to legacy products with, scripting required, iRules, and so on, those use cases on Avi can actually be done using policies that can be configured from the UI. So what I did here on this VIP, I created two policies. And policy 1 says, if the path contains pool 1, use this pool. However, if the path contains pool 2, use content switch pool number 2. What I did on my web servers, on web server 1, I created a directory called pool1 with this content in the index.html file, just saying pool1. And on web server number 2, I created a directory called pool2 with pool2 inside the index HTML file. So let's grab the VIP of this application and go back to the test client. So if I have pull 1 in my path, I should land on server number 1 and get pull 1 as the response to the request. And similarly, if I change the path to pull 2, I'll get pull 2 as the response to my request. Once again, let's take a look at the Avi logs to see what happened here. So I can see that this is a GET request. The URI was pull 1. And I can see here that the load balancing decision was made based on a rule. And I can see that it landed inside the pool content switch pool. Whereas if I open the second request where the URI was pull 2, load balancing decision was made based on rule 2, and the request made it into pool number 2 according to the rule. The last thing I will show during this demo is how we treat failovers. So what happens if a service engine goes down within OCI? So I have both service engines here running happy and green. And what I'll do is I'll simply kill one of them in a non-graceful way. So the service engine on this host was killed. If I switch back to my UI, my controller will detect that there's a failure in that service engine. The controller is unable to communicate with it. Heartbeat messages are not getting responses. So now this service engine is being marked as down. So from the application perspective, I can see that they're still up and running, but complaining that, hey, we need 2 service engines for high availability, only one is available. This will, of course, trigger an alert. If I look at the OCI perspective, if I look at the service engines, then I can see this is the service engine 83 SE2. So this is the same service engine that I killed. I can see that it doesn't have any secondary IP addresses anymore. It only has its primary IP. The secondary IPs that were placed on it were actually moved by the Avi controller using an API call to OCI. Those secondary IP addresses were actually moved to the surviving SE, the one that stayed up and running. So this is how we treat failovers within OCI. And this happens within milliseconds and will have a very minimal effect on your traffic. So in the meantime, the controller should have detected the SE failure and restarted the SE. So we can see in the meantime, we can see the slight dip here where we killed it, but in the meantime, the controller was able to restart the SE and it's up and running again. And if I look at my applications now, I can see that they're again placed on both service engines as active-active. And this concludes the Avi integration into OCI demo.